everyone. Thank you for joining us on such a lovely day. I'm happy that the weather turned out much nicer than the forecast originally said. So as Liz was saying, we're from Mountain Equipment Co-op, and we are all members of the materials team. So any product is made up of materials, key component of that. So there's different components within the materials team. And of course, the end goal, really, all these different pieces come together to highlight materials performance and assurance. We really want to make sure, at the end of the day, quality is kind of that key thing that holds everyone together. So jumping actually back just to say what's the talk on. In the context of materials, just touching on the footprint that those have on the environment in general, and what are some strategies and tools of trying to reduce that footprint. So we'll start with the challenge. One of the challenges is within any organization, there's different viewpoints. Everybody has a different view of what they're looking for. This is a highly simplified diagram. I mean, there's other circles that you could have out here for sourcing and for social compliance and all different aspects. But as a simplified overview, you have the design team who's really focused on designing the products. You have the product managers who are trying to determine the relevance and figure out how that assortment fits at a retail level. And then, as we touched on, there's the materials team. So between each of these teams, you have different drivers. Some of the drivers may overlap between different teams, but at the end of the day, everybody has the same goal of making a relevant product. It has to be relevant, because if it's not relevant, you could have the best product out there, and it's not going to sell. As Liz was mentioning, my background is chemical engineering, and one of the key messages that they like to reinforce to us is that it doesn't matter if you have the best idea. The marketing is what's going to make or break that. So it's a reality of the situation that if you can't get your message out there, if you can't speak to your product, if you can't make it relevant, it's irrelevant. So that's obviously one of the key things there, is that there's give and take between all these different asks, and it's trying to balance all of those. One of the other challenges associated with that is that there's timelines behind all of that. It's saying, okay, we need to have this product developed for a year from now. That means you have so many days to find what we're looking for. So a typical season would be up to 80 materials and finding those in a 90-day time frame. So you have to react very quickly, make decisions, and that makes it challenging as you start adding on more and more asks. Price is another one that is always a challenge. Textiles are really in a unique position in that clothing and footwear is the only portion of the CPI, Consumer Price Index, that has actually fallen since 2002. So each year in nominal dollars, so not adjusted for inflation, it's getting cheaper and cheaper to buy clothing and apparel every year. In again, those same nominal dollars, the price of clothing and apparel, a basket of clothing and apparel, clothing and footwear, sorry, is the same now as it was in 1990. And in 1990, adjusting for CPI, the dollar was worth, that went 60% further. So as kind of shown here, the amount that we spend on clothing is decreasing as a percentage of overall budgets, but expectations on performance, on quality are always the same. So it's always a give and take of how do you hit the cost requirements that consumers are expecting while still balancing all the quality attributes. And then you get on to adding additional quality things as you start digging into the supply chain. So textiles, how much actually gets used and made each year. And this was certainly one of the things that I found interesting when I came into this field was, you know, clothing, apparel, textiles, they're all over the place, but we don't really see the impact here in North America. It's a huge industry that's ever evolving, and it has a large impact on the environment. So again, the amount of textiles produced, enough to cover the state of California, that's a lot. Pollution, very big contributor to pollution, water pollution, air pollution, all those things. Again, one of the ways to cut costs is to turn a blind eye to things. So it's saying, what do you do when you have all these different chemistries that are applied, especially because textiles is a very chemical intensive process. There's a lot of substances that go into a single piece of textiles. You have your dye stuffs, you have dye auxiliaries, you have everything that goes into making that product. There's different classifications and different mix mash of chemicals and chemistry, and it goes on and on. We'll get to that in a minute. So again, the three kind of main areas of impact. You have your chemical use. Study by Greenpeace says that 25% of chemical use worldwide can be tied back to textiles. So again, pretty big impact. Water use. Cotton especially is a fairly water-intensive crop, but beyond the growing stage, even for your synthetic materials, there's a lot of water that goes into the processing when you're doing your dyeing, when you're doing your finishing steps. So the impact of the amount of water used is big when you multiply the fact that we're producing enough textiles to cover the state of California. And energy, any industrial process is going to struggle with energy use and trying to take that in context. So a typical, very, again, simplified overview. You have your facility that's making your textile. You put in raw materials, water, and energy. You get out your product at the end here. But what you also get is you have your wastewater, you get other solid waste emissions, you have all your air emissions, so you have the normal gases as well as ultrafine particles, noise emissions as well, something that's often overlooked. And again, looking at the end textile, what you don't realize is that 10% kind of at the high end of the chemistry that's used in the process makes its way into that final product. So if you look at a typical t-shirt, the weight of that, you've got 10 t-shirts of chemicals that are used further upstream. And again, the supply chain itself is very complex. As you try to find, as you move further and further back into the supply chain, it gets more and more granular. So here's where we are at this end. Here's people. Well, actually, I guess we're one step further here. But here's all the retailers. Here's the shops where you go to buy stuff. There's a lot of them. Each of those shops carry some brands. The brands are building product. They're buying material and other things. They may either be buying it from the raw material suppliers themselves, so we call that tier 2, or they might even be buying it just through agents or from the factory. So it's possible to not even have any visibility into this part of the supply chain. But you can see in here it gets quite complex because you have all the different types of finishes. One facility might not finish a complete material. You may have different people doing different things. Somebody actually making the yarns, somebody weaving it into a fabric, another place dyeing it, another place applying any coatings that you need. And each of those places have their supply chain of all the chemicals. So the further and further you try to go, the more and more complex it is if you're trying to manage that. So again, we see final product. That's what we're all familiar with. But what you don't see is all the impacts that lie behind the scenes. So you can't, when you're looking at the final product, you can't test for things like how much chemistry was actually used to make that. You can get a sense of what's left, but you can't get a sense of what was actually used. And again, it's quite a bit. You can have equal weight of the chemicals per kilogram of textiles alone. Water emissions, again, you can't, by measuring and looking at your final product, you can't see the water emissions that are happening. You can't say, was it done in a responsible way, was it not? Air emissions, same thing. What are the impacts? It's something that you can't measure on that final product. Waste management, again, is it actually being disposed of properly according to best practice, or is it just going out in the back and being burned? That was just for the mills. You apply that same logic at the chemical supplier level because, again, they have products that they're selling. They're taking other raw chemicals and turning it into other chemical products. And the same issues apply: waste, water, air, all those things. What happens with those?
I'll just jump in quickly. I can't help but say this point, as a retailer and a brand here, this is the topic that nobody discusses. So everybody wants to know, is this product safe for use? So we try to come up with things in this regulatory compliance around chemistry used on materials. And that is primarily where the consumers focus their attention. So the discussion doesn't go further. But by far, this is our greatest impact that we're trying to deal with. So for us, we're reaching out to everybody to try to figure out how do we communicate this and how do we understand this as a global issue. And given that North America and the Western world, we're the high consumers of all these end products, and how do we deal with these types of things on an ongoing basis? And so for us, it's building out that community. And I don't mean to interject here, but that's such a critical point for us to just emphasize on an ongoing basis, is you have to ask a lot more of those questions. And it's not necessarily that from an advocacy perspective, but we do encourage those advocacy groups to have a voice and to participate in this discussion, because this whole process is so far from our immediate view, but it is the reality of the world that we actually have to manufacture it again. These are, in some cases, very extreme photos, but we try to use filters to try to figure out how do we screen out facilities that do have poor management practices. How do we incentivize those that have great management practices, and try to put those forward and share those with our other brands and retailers to say, hey, look, we think you can do this too, and how do we start to spread this forward to get further collaboration on that. So it's just a really key point that I just want to make sure as to why we as a retailer and a brand are willing to put forward these challenges. This isn't a message that generally you'll hear from a lot of folks, but we all deal with the same issues. We share the same supply chains.
Yeah, thanks, Greg. So again, those are all the bad side there of what are all the things that are stacked up against us in terms of trying to reduce impact, right? Those are all the things that you have to deal with. But on the flip side, there's some opportunities that can be leveraged to help out, to say this is why we need to tackle those issues. So a lot of it has to deal with regulations that are up and coming. I mean, regulations are a driver for any industry. And as the impacts of the pollution, whether it be water pollution in China or whether it be chemical waste, residuals on product, there's increasing complexity of regulation, both at the manufacturing level but also at the final product level. And one of the opportunities is to address that by knowing your supply chain and being able to increase your strength of your supply chain. The more you know it, the more, not control, but the more at least you understand where your risks are, and you can manage those as opposed to just being blind to them. And as Greg was mentioning here, consumers and what consumers are asking is also a driver, and it's when consumers are asking the right questions that can really push change in the industry as well. So, making progress, and this is definitely one of my favorite comics of probably all time. I mean, what's the downside to trying to improve your supply chain and improve the impact that you have on the environment? Is there one? Yeah. So, how do you go about reframing the discussion and being able to tackle this and get others to really get on board? So one of the ways that we've done that within our organization is trying to reframe sustainability as product quality, because ultimately at the end of the day, they are interrelated. So again, if you can reduce the risks of your supply chain disruption, that is a benefit. If you can reduce the supply chain interruption risks because of changes to legislation or changes in chemistry input side, that again is a benefit. And again, if you can improve, if the better chemistry, just like garbage in, garbage out, the better chemistry controls that you have input, the better controls you have on the output in knowing what you're going to get. Less rejection, less delayed shipments. All these things are kind of key metrics that any business looks at, and if you can reframe it as part of those metrics, it makes the discussion a lot easier one to say. It's to say, hey, we think we have a way to help improve these aspects of the business. It just so happens to reduce impacts in other areas as well. And again, the key is that you end up with a proactive versus a reactive approach. Rather than having to wait for an issue to appear before you try to address it, you know where the risks are and can start to manage those. So again, part of it is what are the ground rules, again, in the business context of how do you develop a product that is going to work within the market and is environmentally friendly. Performance can't be compromised. It has to meet the performance targets. If it isn't hitting the performance targets, then it's not the product that you're trying to develop. Value, again, if it can be the best product in the world, if people aren't going to buy it, it's not relevant in the market. Transparency, making sure that you're not making false claims, that what you're stating is true, because that ties back into, again, consumer education and awareness. If there are questions, being able to say, wow, I thought it was this, but actually you're saying it's this. Can I get more information on that? And being willing to recognize where those challenges still lie. And then working within the industry to share common goals. So it's not a competitive advantage or it shouldn't be a competitive advantage to be, the greenest company out there or to do these type of things. These are all things that everybody is struggling with. It's to say, well, why can't we all work together to address some of the things that we have in common? And we all struggle with supply chain. Is there a way that we can move that forward as a group? So following forward into what are some of the tools that we have or some of the frameworks to work within where we can start building some of these things in. So again, touching on the performance side of things, product has performance expectations. There are guidelines that have to be met. There's specifications and standards that have to be met for that product to be deemed what it was intended for. Different products have different requirements. You can't have one large bucket that covers every product. It's recognizing that an insulated ski jacket is going to be different than a lightweight wind shell, and how do you recognize what the differences are? And that's where that quality part comes in. And then again, being able to test to it and being able to make those determinations. So getting the product out in the field, making sure that it actually performs. So that's what happens at the material or at the product level. On the material level, it mirrors it in a lot of ways. There's a little bit more granularity, just because again, the further upstream you are, the more time you have to to look into a few more things, and the easier it is to look at things as individual components before you assemble it into a final product. So similarly, you still have requirements that are grouped by intended use, that you're saying this material is meant to be used in this type of application. It has to meet this set of requirements. And then it can be validated both, again, through that field testing at the product level, but also at the lab testing stage. So saying, what can we start looking at before we get it into a final product to see if we're going to have any problems? Again, trying to move as far upstream as possible any challenges that might exist. And again, these are things where you can look at things as simple as the production attributes to say, okay, what, how much material are you going to be able to give me? What's the price? All those things. But also being able to look at the actual physical and functional attributes of the material itself. How waterproof is it? How well does it shed water? How breathable is it? How strong is it? How likely is it to tear? Color fastness, is that going to be something that's going to be an issue? Another area that was quite interesting to me was seeing actually the amount that is done on color with a product. You have every little piece has to be matched to the right color, and of course, if one of those colors starts to fade faster than another, that's a problem. So all these things that go into a material consideration. And again, remembering that you have 90 days to develop 80 of these. So you already have these things, and now we're saying, well, can we add on sustainability attributes? And it's like, you're already asking for this, and you want me to add more things in there too? But there is a process here where at least there is a mechanism to add some of these things in if there are the tools to help make those decisions for you. Oh, yes. So one of the other sides is on the supplier shirts. What knowledge do you actually need in order to, again, start making some of these things? So on the product sustainability side, you need to understand what the environmental health and safety requirements are to be able to start making some of those, or asking the right questions. How do you ask the right questions without knowing what to ask? Understanding what the technologies are, what the limitations of the technologies are, both from a process standpoint as well as the material level, to say, how do you make a decision of saying, okay, I want you to develop something that is better? How do you start to define better, realizing that certain processes are going to have limitations to what you can do within those? And then again, just getting into willingness and transparency. You have to be flexible. You have to be willing to work together.
I'll just jump in quickly, just back to the other slide, just to add some context there. We add product sustainability in here, and this is definitely typical of industry, that we say, here's what we're trying to build, and then I wonder if we can pull upon some product sustainability attributes. And in fact, they're one and the same. We just happen to use a different vocabulary, and that's been part of the problem. That if you go upstream into your supply chain, you talk to operations managers, production managers, technical engineers, all the metrics we use to understand product sustainability are metrics for our operational efficiencies. Yet we insist on using a different vocabulary. And so we're really trying to get back to those roots of efficient, knowledgeable, intentional manufacturing processes, what you select as inputs, how do you actually go about doing that. And part of that is making sure that, when people say, well, at a certain region, you get product, bad quality. Bad quality is intentional. Either you can spec good quality or bad quality. So quality is truly a sustainability effort, because if you can build reliable first quality goods, make it relevant to market, make sure you have that durability aspect, you definitely have the potential of less throwaway. The fact is, consumer behavior is a different aspect that we have much less influence on, and how do we actually control that? But we're trying to do our part in making sure that we get good quality goods. So all these things have sustainability attributes. So this is the material requirement. And as we get into the next slide, or what Joelle was explaining around supplier side, you have to be able to match supplier capability with your material requirement. So we try to go through a similar process of how we assess our suppliers. Do they have the technical capability to do it? Do they have the management oversight to be able to do it? Do they have proper training? All these things are investments that somehow slip between the cracks when
So again, getting into the how, willingness to act is key. You have to be willing to jump in, even if you aren't sure 100% that it's the right course of action. Sometimes you got to rely on that gut feeling and say, we think this is the right thing to do. Integrating it into existing workflow is so using that common set of language, it helps streamline the conversation to make sure that it's not just something that's being tacked on, it's something that actually makes sense within the overall scope. And then again, being able to use tools to help streamline some of those decisions so that it isn't impacting your ability to make decisions elsewhere. So one of the things, kind of throwing this in there, is being willing to also celebrate those incremental wins and saying, I mean, yes, it would be great to be able to do something all at once, but it takes time. It takes time to be able to make change, and we have to be willing to recognize that, but also be willing to say, what is the progress we're making? So we have a corporate goal to use 100% blue sign materials for 2017, and here you can see our progress over time. So we're heading in the right direction here. We're quite happy about that. Organic cotton now is another decision to say, should we, is there a benefit to organic cotton? Should we be using organic cotton? The decision was made yes, and now all the cotton that we're using is organic cotton. PVC saying, is that something that is the most friendly of materials? Is there alternatives? We think there are, therefore let's phase out PVC. And again, constantly driving constant improvement. So trying to not remain complacent. You always have to be willing to move forward. If you're not, you're just kind of standing still. So, getting onto the footprint, again, what is some of the other aspects that tie into sustainability that we can leverage in terms of language or techniques, what to do, what not to do. So at product manufacturing, you likely have heard of social compliance things where, again, go into a factory, make sure that they're not doing child labor, that you're paying overtime accordingly, that they're making a living wage, that you're not taking their passports and locking them away, all those type of things. It's growing in, it's fairly, I'd say, known now in consumer space. That covers a little bit of chemical use, but not much. It's mainly intended to focus on the worker level. You have your product performance claims. These are, again, things that are consumer facing that people can know. So what are the things like waterproofness, breathability, numbers like that. Looking at your product claims on traceability, so looking at whether you're claiming organic cotton or recycled content, all those type of things. Now as we try to do material processing, again, you're trying to address the impact in the supply chain. Water, energy, these are things that, again, there's existing tools and mechanisms there. But chemistry is really that big. It's always kind of been an outlier of how do you assess and make decisions around chemistry. So that's kind of what we're going to talk about next. Chemistry, again, quick slide here, just showing everybody. It's a challenging topic because nobody is really sure where it should live. Everybody is saying, well, how does it affect me? This is what's critical to me. Now you're asking for this, and everybody kind of comes from a different viewpoint here. Back to our complex supply chain. So kind of what's the current way of addressing chemistry? It's to say, okay, well, here we are way at this end. If we just tell you not to use it, you're not going to use it, right? So we'll just give you a list, say you can't use any of these chemicals. If we test it, it shouldn't show up. And thank you, please sign this paper. It's a great paper shield here, depending how you use it. It's a tool, but it can also just be a paper shield. So you're saying, here's what you have to do. And of course, you may get your tier 2 suppliers to sign it. It might even be the factory that's signing it. somebody is signing it before you get the product. But of course, they have no control over this part either, and they're kind of like, I don't think I'm getting that, so okay, I'll sign that. But it's not actually making any change in the supply chain. You're kind of just hoping that it's good unless you have some ability to actually drive change and audit further into the process. So that's where we're saying, well, what are the alternatives? And we turned to BlueSign. And BlueSign was a system that worked with both the chemical manufacturers, the mills, right through to the brands to say, how can we make sure that you're getting materials that, A, are being made in a facility that has an awareness of best practice and is following best practice. So that covers things like emissions, but also process efficiencies, as well as are using chemicals in a controllable and known way. So it's saying, yes, there might be impurities as part of that process. A good chemical manufacturer will know what those impurities are, will be able to do spot checks to be able to manage those, figure out what the tolerances are. And if you take those into account with regards to what's happening at the mill level, plus the equipment that's used, if you kind of develop this whole model, you can have a pretty good understanding of what's going to come out on the output. So you're saying, we're going to look at it from the input side. Again, the further upstream we can go, the more time you have to react. Again, with the RSL approach, if you find a problem, that material's already been made. What do you do in that case? You have limited options. Whereas here, you've moved further into the supply chain, you might be able to catch it earlier on and do something about it. So again, working with all those different stakeholders, one of the challenges is everybody has their own IP, and they're like, well, I don't want to disclose that. This is a mechanism that allowed people to do so in a way that was comfortable to them. So again, now actually they're working all the way through the supply chain to say, here's how we're managing this, looking at it from an input side. So it helps with meeting your end criteria on any restricted substances that you do want to control. You can say, I don't want these on product. By screening the chemistry that goes in and working with the mills that know how to use those properly, you can prevent that on the output. And as part of that, again, if they are following the best practice of process equipment, you can also address the emissions at the same time. So making sure that there's the proper emissions control and everything there. So it really kind of we feel was a holistic approach to environmental management systems around chemistry. So now you have to be able to explain that to your supply chain. And again, one of the measures is to use key performance indicators as part of a scorecard to say, these are the things that are important to us in what you're giving us. So that could be things like, again, lead times, order quantities, all those type of things on a very planning side of things. On our side, interested in things like the quality assurance and the research and development. How responsive are you in terms of being able to understand what we're asking for and be able to develop and deliver that material? How good are they at working with the factories? But then now it's also a means to say, again, within that framework, the environmental and social impacts are important to us, and we're going to evaluate you on those as well. So are you a BlueSign facility, yes or no? Are you able to offer us BlueSign approved materials, yes or no? Those type of questions. So again, that gives a ranking of suppliers as well, because not everybody is always going to be at the same place at the same time. And that's fine, but it's saying how do you start to rank those and be able to make decisions around that. Kind of gets back to the topic of how do you manage risk. If you know what's there, you can do that. So you have, just like with a technology, you might be able to say, this mill is really good at providing us this technology. This one, not so much, so we might want to check this a little bit more closely. And this one, that's not their core competency. We shouldn't be asking them to develop that for us. Same on the environmental side. You have this supplier is able to offer fully BlueSign approved materials. Great. We know that that's minimizing the risk there. However, not everybody is able to do that, so then how do you start to tier that and make decisions around that? So number 2 is saying, well, at least do they have access to an input list of chemistry that they can start to screen against, yes or no? Still have to do some screening on the output of are they managing, is anything showing up on product, but at least we know they should be capable of it if they're using that input list. Going down one more level, of course, you have no screening. You don't have that transparency into the chemicals and processes that are going in. Here, the restricted substances list and testing become really important, and you're probably going to have to test more often because, again, that test only gives you a snapshot in time, too. So you might have tested the one batch that was good and all the rest are bad. Or you might test the one batch that's bad and all the rest are good, but you have to be able to do enough testing to understand what the actual performance is there. And be able to analyze the results too, to say, here's what we were asking, here's where the value fell. Is it meeting, number 1, it has to meet Canadian regulations. That's non-negotiable. If it doesn't meet Canadian regulations, legally cannot use that material. It's garbage. If it meets Canadian regulations, does it meet global regulations? Again, saying if it doesn't meet global regulations, I mean, how can that facility operate knowing that it may be supplying materials into that market where that's failed? So that's a pretty big red flag there. And then it's saying, does it meet industry practice? And again, at the higher level, is it meeting the criteria that BlueSign has? So BlueSign, as part of their system, they've said, and this is what we're controlling on the outputs. Here's all the chemicals that we're screening on the input. Here's the limits that everything should be meeting on the output. And that's kind of a little bit above a lot of the restricted substances lists that are out there.
Just gonna interrupt you for a second. I know we were having trouble accessing the clock. Can you just let me know it's connected?
Perfect. So give it to the rest here. EPMs, one other area here. Environmentally preferred materials. So we talked about chemistry. That's one aspect here. You have all these other things that you want to do with materials. Again, supply chain equally complex as chemistry and the rest of the supply chain. So again, there's lots of different types of environmentally preferred materials, and it's saying, well, how do you start to make choices around those? There's different ways of doing traceability. Traceability is a pretty good way of measuring against those because a lot of these environmentally preferred materials you may not be able to differentiate in any other way. How do you know if a down cluster has come from a farm that is treating the geese well or one that's treating the geese poorly? You can't unless you have ability to look back into the supply chain through a traceability mechanism. So again, all these things that we're saying, these are things that we think are better. But one of the things is, well, how do you actually validate that? And that's one of the challenges that it always exists. Life cycle analysis is one of the means to do that. Sometimes you have to make a decision before that's readily available. You say, you know what, we think this is the right thing to do. We're going to move forward. That's what happened with organic cotton. Recently, organic cotton life cycle analysis came out, and we're quite happy that it actually shows that there is a pretty substantial difference between organic cotton and conventional cotton. Not always the case, but in this case, it was a pretty good difference there, kind of validating that decision. Last point is collaboration. Last point? I think it's the last section. Collaboration, again, talking about how do you work together as an industry to be able to move forward rather than just everybody siloing and doing their own thing. So there's many different groups that work together on different initiatives for different purposes. Higg Index is one of these. It's kind of a means to benchmark and assess facilities, materials, and be able to talk in a common language. So if I'm saying my recycled material is the best, it's better than everybody else's, well, how do you prove that? I mean, one way is, again, having life cycle analysis, but at least can we speak in a common language and say, well, here's how you need to be able to show that you're, if you're saying you're better, what are you actually better on and why? So here's a list of questions. Can you screen yourself? and be able to make some of those choices there. Again, one of that is a material level. So being able to say, how do you determine is a polyester better than a nylon? Is a cotton better than hemp fiber? Being able to look at some of the numbers and look at what characteristics are valuable to you as well, because it might be better from a water perspective, but worse from a chemistry perspective, or vice versa. So saying, okay, we're trying to improve this, therefore that's the decision that needs to be made. Chemical management module. This is one of the things that's being developed by the Outdoor Industry Association. This kind of gets back to knowing, establishing a framework and knowing the questions to ask. If you can put together the questions to ask, if everybody's asking the same questions, it's much easier to get a response, right? If I'm asking this question, you're asking a little bit different question, gives a lot more wiggle room there. So conclusions. And this is an interesting comic here. I think it applies somewhat to university as well. Often we learn in silos, and that can be a challenge when you go into workplace and everybody has to work together. Again, you have all these different viewpoints of opinions. So how do you work together if you don't learn together? And that's always been interesting takeaway. So conclusions, everything is connected. Don't want to work in individual silos because it doesn't allow for forward movement. Tools and frameworks, these are really critical in being able to help make decisions on a timely basis. Community of practice, being able to work with industry peers to move together as an industry. Rising tide rises all ships, raises all ships, raises all boats. Being able to have that common set of language and asks helps move that forward. Being willing to benchmark, document, report, and as part of that, set goals. If you set the goals, you figure out how you're going to measure against that, and you report your progress and be transparent. Hopefully, it really helps make sure that once you've set that line in the sand, there's much less discussion over whether or not you should move in that direction. It's saying, well, there's the line. You're moving in that direction. It starts to go from a why to a how. And then again, being willing to also celebrate those incremental wins, because it might take a long time to actually get where you want to go, depending how far out you set that goal. But saying, look, we have made progress in these areas, and being able to be happy and celebrate those so that you're not constantly looking too far in the future. A book, if anybody gets a chance, awesome book on kind of the chemical industry in the U.S. Well, it kind of gives an overview of chemicals in general. It talks about one specific plant in the U.S. Where they are. It focuses a lot on the profit, challenges of profit, and knowing where there were some issues and still choosing to make decisions strictly on profit. So again, the end goal is a net sum game, and that's really what we're trying to drive towards. So thank you.